Welcome to Battling Model Decay with Deep Learning and Gamification. My name is Sinan Ozdemer, and I'm the Director of Data Science at Directly. As many of you know, machine learning models degrade over time, and this is due to a variety of reasons, one of which is shifting trends in data. To keep the performance of machine learning up, continuous upkeep is needed. Upkeep is unfortunately expensive, time-consuming, and often a very reactive process. Now, Directly proactively and continuously enhances virtual agents by leveraging community experts to boost automation rates and help fellow customers. We do this by providing an AI platform and a gig economy that helps our companies transform customer service by tapping highly skilled product experts from around the globe to help our customers and make a partner ecosystem to help them analyze data, author automations, and engage with their customers to give personalized answers. Now, in this talk, I'd like to talk about three main areas of our machine learning pipeline. I want to talk about how we run daily deep learning-based clustering algorithms on recent customer inquiries in order to capture new automation potential from trending intents. I want to talk about how we take these trending intents, validate them, and send training tasks to our gamified intent discovery and training platform. As we discover these new intents and automate them, I want to talk about how we update triage algorithms to effectively route incoming inquiries to either our automations, our experts, or our customers' internal agent network. So let's start with our trending cluster analysis. The core of our Understand product begins with our daily cluster analyses. And as we say at Directly, this really is the voice of our end users. Our Understand product, as we're seeing here, gives our clients real-time insights into what their users are asking and what they're talking about, and how Directly is taking action on these inquiries. On the right, we offer up the top automated insights from our cluster analyses to show our customers which opportunities we are actively pursuing for deflection and automation. In order to stay up to date with our customers' latest clusters and intents, we developed a clustering pipeline leveraging much of Databricks technology. Raw questions are ingested and stored in the Delta Lake. These questions are encoded using deep learning and then clustered in a high-dimensional space. These cluster maps are then streamed immediately to our in-house automation operations teams, as well as our clients' dashboards for transparency from that Understand product, which I previously showed. This pipeline of ingestion, encoding, and clustering runs at least once a day per customer, and oftentimes even more, so that we are always surfacing the most urgent and largest clusters ready for automation. Now, let's take a look at what this really looks like. Let's take a closer look at the raw cluster analysis coming out of our pipeline to see how quickly trending intents can rise and fall. We are looking at the beginning of March 1st through the 15th, for one of our large global travel and hospitality companies, which is one of our clients. They have just issued a statement regarding their COVID-19 refund policy. Our cluster pipeline is outputting tightly packed clusters of questions on the left, all around people asking about location-specific refund statuses. We can see that in some of the clusters, people are asking about their reservations in Disney, in Israel, in Canada. Being able to isolate these location-specific questions and with this granularity allows us to author automations that are highly tailored to our end users' needs. Now, we still see clusters like the one on the right corresponding to more longer standing intents like troubleshooting editing profiles. But these clusters at this time are much lighter in volume in comparison. Now, let's look at the same company, same source of data, 2 weeks later, March 16th through the 31st. We no longer see as many of those location-specific COVID refund questions on the left, but they've actually been replaced with questions from people who have already submitted their request for a refund, and now they're asking about the status of said refund. This is a potential new source of automation that did not exist 2 weeks prior. And if we hadn't have caught this, we would not have been able to deflect it. Intents, and therefore opportunities for automation, can rapidly rise and fall within weeks and sometimes days. It is relatively simple to focus on longer standing intents like profile editing troubleshooting, but only truly proactive data pipelines like ours are able to act on these intents that can vanish as suddenly as they arise. Now, of course, I was able to label these clusters for us fairly simply for the purposes of this talk. But in production, clustering is only the first step in this process. We also have to be able to effectively utilize the raw output of these cluster analyses in our pipeline to automate these intents. To be able to continuously and confidently detect these trends in our clustering pipeline, we also developed an intent discovery and training pipeline that is capable of producing results to enhance our AI models 24/7. It is based on the theory that among the clusters like the ones I just showed you, there are potential intents to automate and therefore deflect for our clients. The questions that were extracted previously to the Delta Lake and clustered go through a secondary pipeline to highlight potential clusters and trending intents. These clusters are flagged for review via proprietary automated process of Directly's making and are validated as new intents by a specialized team of in-house automation specialists. These automation specialists confirm the new intents coming out of the cluster analysis, and once these intents are validated, further data labeling tasks and training tasks are sent to our global network of experts through our gamified training platform, seen here on the bottom right. The results of these tasks, which are trained 24/7, are, among other things, training phrases for our natural language models and authored automated responses for said intents. If you think back to our previous example, intents surrounding location-specific COVID refunds can be sent immediately to our training platform to author automations within days and sometimes hours. Directly's ability to draw on the collective knowledge of experts around the world to continually train our automation AI and automation pipelines sets us apart in a big way. Let's see what this looks like. We are looking at a graph of an automation classifier's match rate percentage for one of our clients. We are specifically looking at the performance for the first 30 days of this model's lifespan, so not that long. In the first 2 weeks of our engagement with this customer, we deployed an industry-specific model that is able to capture intents from the industry that the client belongs to. We were able to fine-tune that model with a sample of data provided to us prior to the engagement. This way, we are able to capture some intents and automations that are a bit more specific than an industry model. Now, that's only in the first 2 weeks. As questions were coming in during that 2-week period, we were sending these tasks that we were previously talking about to our global network of experts through that gamified platform. These tasks are then used to validate and train new intents along with our specialized team of automation experts and fine-tune our natural language model with company-specific intents and automations that are not going to be found in an industry-specific model and were not captured from our sampled data. 2 weeks after launch, where that orange arrow is, we turned on the updating of our natural language models from the trainings from our expert network. We can see that within days, our intent match rate for this one classifier grew by 150% and has since continued to climb steadily. This is showing how our distributed training pipeline is able to train natural language and automation classifiers without having to rely on reactive teams, in-house reactive teams, and therefore can be more proactive about finding these new intents. and automating them. Now, our global network of community experts are always training our AI models, but that's not all they're doing. They're also engaging with our clients and users and answering the questions that our models are not successfully able to classify or contain. Our deep learning-based triage system, which we call predictive routing, is charged with the task of routing questions to our network, incoming questions to our directly network, and sending the end user to the optimal customer journey, whether that's with one of our automations, one of our experts, or back to our client's internal agent network if it requires specialized access. This is yet another pipeline that relies heavily on Databricks that we employ to make this a reality. Questions that are attempted by our experts, and therefore were not able to be contained by our automation, are normalized and fed into our predictive routing triage model training pipeline, and the results are tracked via ML flow. The predictive routing models, very similarly to our clustering and intent models, are updated at least daily, and they are always learning from our experts' recent behavior patterns of answering questions. What this all means is this allows predictive routing to more accurately and effectively and quickly predict expert behavior and route questions to our expert network that have the highest chance of resolution with a high CSAT or NPS. All other questions that are rejected by predictive routing are either fed into our automation pipeline or sent back to the clients if our predictive routing model has detected that it requires a higher level of account access than our experts or automation are able to provide. Now, let's see what this looks like from one of our large gaming companies' case studies that we've provided. Now, we are looking at the performance of two predictive routing models for this large gaming client. The purple line represents the performance of a predictive routing model that is being trained using the pipeline I just outlined, being trained every day, learning from the most recent expert behavior and trying to effectively route questions with the highest chance of resolution. The orange line is the exact same predictive routing model, but with continuous training turned off, and it is only trained on the initial day and then never trained again. Now, within the first few days and the first few weeks, we see that both models' performances are about the same. They rise and they fall due to the types of questions being asked by the network and by the end users. Now, it is worth noting the purple line, which is continuously learning, is generally above the orange line, but not by that much. On September 21st, the company, our client, experiences an outage for their most popular global online game. Both models are inundated with several new intents all asking about the outage. When is the outage going to be over? What is causing the outage? When is this going to be fixed? Our community experts were there handling the backlog of tickets that our automations were not able to handle because they had just never seen these intents before. And this is true for both models. The difference, however, is the purple line, the one being trained daily, is learning from the expert's work every single day. That model is quickly recovering in routing performance, while the orange line, who is still only learning from data from day one, decays much more rapidly and takes a much larger hit to performance and only recovers when the outage is over and people just stop asking about it. The purple line recovers much quicker because it is able to understand these new intents coming in and understands which types of questions that our experts are able to handle and resolve with a high CSAT or NPS. So this goes to show that continuous training is not only for our clustering, not only for our intent classifiers, but it is also being used to optimize the expert network that is supporting all of our AI models. Continuous training of models is imperative to a modern, effective machine learning pipeline, and it greatly improves the experiences of both our clients and our clients and users. In order for Directly to proactively capture automations, capture these new intents, and optimize our expert network, we must be able to surface potential intents from daily trending cluster analyses. We also have to validate these potential new intents with our specialized automation teams and automatically send training tasks to our global network of experts for further training and fine-tuning of our automation models. These expert networks are able to keep the quality of the machine learning high, like we've seen in previous examples. And lastly, we must always be optimizing the expert network supporting our automation. And we have to do this 24/7, because as these new intents come in, as expert behavior changes, our predictive routing, our deep learning triage models, have to maximize resolution rates, maximize CSAT scores, all while understanding which questions are going to be most likely to be flagged for automation or sending back to our client's internal agent network. Now, all of this is possible through Databricks, and it is necessary to stay relevant in the market's growing demand for proactive, intelligent automations. So thank you. Thank you for sitting here and listening to me talking about battling model decay with deep learning and gamification. I hope each and every one of you will go back and really think about the pipelines that you are building and whether or not they are ready to continuously be updated and optimized so that you're always capturing all of the latest shifts in data. Thank you very much.